So I am working on this KY-038 sound sensor module, and as it appears it has 4 pins: VCC, ground, an analog output pin, and a digital output pin. The main component on the board is a microphone. So the type of microphone used on this board is a condenser microphone. There is also a potentiometer, a LM393 dual comparator, 2 built-in LEDs, and bunch of resistors. So to understand how these things operate together, let's take a look on the schematic diagram. The circuit is powered by a DC voltage VCC and ground pin. We can see that once they are connected, the onboard LED 1 will turn on. The LM393 has 2 independent comparators, U11 and U12. The microphone detects sound and converts it to an analog electrical signal. So the output of the microphone is fed into the first comparator through the resistor R3 and the potentiometer. And basically how a comparator works, it has 2 terminals, the input voltage and the reference voltage. If the input signal is higher than the reference signal, the output goes high. If it's less, it goes low. So here the input signal is derived from the voltage divider formed by R6 and R2, which is VCC over 2 because they have the same resistance. And the reference signal is resulted from the potentiometer and the microphone output. So based on the comparison between these two signals, the output is either 0 volts or 5 volts. So it's either high or low and it's connected to the digital output. I can see also that when a sound is detected and the output of the first comparator goes high, the output of the second comparator goes low, because the input voltage of the second comparator, which is VCC over 2, is lower than the reference voltage, which is VCC, which leads to LED 2 turning on. So the first LED turns on when the board is powered, and the second LED turns on when a sound is detected. For the wiring part, to connect the sensor to an Arduino microcontroller, VCC should be connected to the 5V pin of the Arduino, GNT should be connected to the GND pin. The digital output of the sensor should be connected to any digital pin of the Arduino. It can be a PWM pin or a regular digital pin. The analog output pin of the sensor should be connected to any analog input pin of the Arduino, which can read values from 0 to 123. Next, I want to adjust the sensitivity using the potentiometer. If the onboard LED 2 is always turned off, I will rotate this potentiometer clockwise to increase the sensitivity of the sensor. If it's always turning on, I will rotate the potentiometer counterclockwise until it turns off, but when a certain noise is produced in the background, it turns on for some time. Now I want to do a simple circuit including the sound sensor. So I want to connect an LED to digital pin number 13 of the Arduino, and I want to switch the state of the LED on and off by making some noise in the background. So for the connection is pretty simple, and for the code, in the first section I have declared the variables. So there's 2 variables of type integer and have been assigned values that correspond to the pin numbers to which the sensor and the LED are connected, meaning that the output of the sensor is connected to pin number 4 and the LED is connected to pin number 13. I also have declared a Boolean variable named switch state, initialized false, and another integer variable named input, which is currently unassigned in this section. In the setup section, I have set up the pin modes. The sensor pin is configured as an input, meaning it will read the signals from the sensor, and the LED is configured as an output, meaning it will control the LED by turning it on and off. In the loop section, the first line reads continuously the current state of the sensor and store this value in the input variable. And this value is either 1 or 0. If the sensor reads high, meaning that a sound has been detected, current state of the boolean is inverted by using current state equal not current state. So for example, if it was false initially, it becomes true and vice versa. And for this line, it uses a ternary conditional operator, meaning that in the digital write function, after specifying the pin number, we pass switch state as a parameter. It acts as a condition. So if this condition is true, the output on the pin 13 is set to high, turning on the LED, And if it's false, the output is set to low, turning off the LED. So every time a sound is detected, the condition is inverted, causing the LED to toggle between on and off. And after this instruction, I have added a 1 second delay to prevent the LED from turning on and off too quickly. So that's pretty much everything about the code. So this was a simple project using the KY-038 sound sensor module.